These are the answers for 1.9 acid base titrations questions. So first of all, what is meant by the term standard solution? We're just looking for a solution for which the concentration is known. Now, an equation for the reaction between sodium carbonate and excess hydrochloric acid. So Na2CO3 plus 2HCl gives you 2NaCl plus H2O plus CO2. Now, part B. In one experiment, a 2.8 gram sample of washing soda was made up to 250 cubic centimetres of solution in a volumetric flask. 25 of this required 22.4 of 0.1 molar hydrochloric acid for neutralisation. Find the value of X using the following headings. So the first one, the moles of hydrochloric acid used, is simply the volume of hydrochloric acid, which is 22.4, times its molarity, which is 0.1, divided by 1,000, which gives us 0.00224 moles. So the number of moles of sodium carbonate in 25 cubic centimetres, that's how much reacted. So we have 1 mole of sodium carbonate with 2 moles of the hydrochloric acid. So that means it's 0.00224 divided by 2, which is 0.00112 moles. So then the moles of sodium carbonate in the sample. Well, the sample was 250 cubic centimetres, and we have found the number of moles in 25. So it's 0.00112 times 10, which is 0.0112 moles. Then the mass of water in the sample. We need to start by working out the mass of the sodium carbonate. So it's this number times 106, which is the formula mass of sodium carbonate, which is 1.1872 grams. We know that we had 2.8 grams to begin with, so we take that away, 1.1872, which gives us 1.6128 grams. So then the number of moles of water in the sample is that mass that we just worked out, 1.6128, divided by the formula mass of water, which is 18, which gives us 0.0896 moles. And then you're just finding a ratio between the number of moles of sodium carbonate and the number of moles of water. So X is 0.0896 divided by 0.001, sorry, too many zeros, 0.0112, which gives us a value of 8 for X. So in question 2, they're analysing vinegar. So 25 vinegar is transferred to 250 volumetric flask. 25 cubic centimetre portions of this are then put into 3 flasks. Drops of indicator used. Titrate each solution with 0.1 molar sodium hydroxide until the end point is reached. So suitable indicator for this titration, you're looking for something which is suitable for a weak acid and a strong alkali, so that is phenolphthalein. And the colour change you would observe at the end point would be from colourless in acid to pink in alkali. So then the equation for this reaction, we've got ethanoic acid, which is CH3COOH, plus sodium hydroxide, NaOH, and that's giving us then the CH3COONA and water, H2O. Complete the results table and calculate the average titer. So here in the first one, 43.1 take away 21.7 is 21.4, and then 21.3 in the second one. The average then is you add those together and divide by 2. That gives 21.35 cubic centimetres. And we use that to calculate the number of moles of sodium hydroxide in the titration. So we're using 21.35 times the molarity is 0.1 divided by 1,000, which is 0.00213 moles. We then use that to calculate the concentration of the ethanoic acid in the diluted vinegar. So we're just multiplying by 40, so that is 0.002135 times 40, which is 0.0854 moles per dm cubed. And then in the undiluted vinegar, which was 250 cubic centimetres, we're just simply multiplying that by 10. So 0.0854 times 10, which gives us 0.854 moles per dm cubed. Okay, so describe, giving practical details, how you prepare the solution of diluted vinegar and then transfer 25 cubic centimetres to a conical flask. I'm not going to write all of the detail here. You can see it in the answers to the fact sheet if you download the fact sheet answers. But I'm going to give you the main points. So the first one is to use a pipette filler to draw up undiluted vinegar until the bottom of the meniscus in the line. So I'm just going to say draw up undiluted vinegar to the line, and of course the bottom of the meniscus should be on the line. Then we're going to say that you need to transfer to a 250 cubic centimetre volumetric flask and make up again to the line with deionized water. Then you're going to invert it to mix. Then you're going to rinse the pipette. And you're going to do that with the dilute vinegar and deionized water. Then again we're going to draw up the vinegar. This is the dilute vinegar. And we want it to the bottom of the meniscus. Is on the line. And then release it into a conical flask. Okay, number 3. 2.65 grams of anhydrous sodium carbonate were dissolved in water in the solution made up to 250 in a volumetric flask. So what was the concentration of the solution? So the number of moles is 2.65 divided by 106, which is the formula mass of sodium carbonate, which is 0.025 moles, and that's in 250 cubic centimetres. So in 1 dm cubed, it's 0.025 times 4, which is 0.1 moles per dm cubed, which is C. Finally, for which of the following titrations would phenolphthalein be a suitable indicator? So we're looking for something which is a strong alkali here. And, well, we know that sodium carbonate is not, neither is ammonia, so it has to be B.